Okay, so titration is to identify an unknown acid or base. So let's say that you found this hydrochloric acid sitting in the lab and you just don't know how concentrated it is. So let's say we have an acid and the molarity, remember the big M, is unknown. Like, is it a 6 molar, like really strong acid that's going to burn you? Or is it like a 0.001 molar that's like really not very harmful? Okay, so somebody left some hydrochloric acid out in the lab and you don't know how strong it is. This is a way to figure out how strong it is. So what you're going to do is you're going to say, okay, well, I have this base over here, and I know that this base is a 2 molar. So if let's say I had 25 centimeters cubed or 25 mils of my acid, and it took 25 mils of my 2 molar base, what does that say about the molarity of my acid? If it took the same amount of base to neutralize my acid, well, it means if this is 2 molar, if it takes the same amount, maybe my acid is also 2 molar. So that's what titration is. It's like adding something you know, a base that you know, to an acid that you don't know and seeing like how much it takes to neutralize. Let's say that it took 50 milliliters to neutralize 25 mils of acid. So you're like, wow, it took twice as much base to neutralize that acid. So maybe the acid is twice as strong. And that's what you do. So you figure out how much of the known thing, like I know this base is 2 molar because it came from a bottle that says 2 molar. That's how concentrated it is, molarity of 2. And I'm like, oh, it takes twice as much base to neutralize that much acid. So it must be that the acid is like twice as strong. So how are you going to know when you've like neutralized the acid? So you're dripping in base. So you're like, okay, let me keep track of how much base I'm adding. Let's see if this is 25 mils. Oh, it took 50 mils of base to neutralize it. Well, how do you know that it took 50 mils of base? So what you're going to do is you're going to add an indicator in there. And the one that they always use is phenolphthalein, because phenolphthalein pretty much is hot pink in a base and it's clear in an acid. So right now it's clear because it's acid. So what I'm going to do is I'm going to add a little bit of drop of base and it stays clear. Drop of base stays clear. Keep dropping in more base. And when I finally get it to first turn pink, I know that I finally got it to go from being like an acid that was in here. It finally kind of tipped the corner. I finally neutralized that acid and started to get it to turn into a base. So as soon as it looks hot pink, now I would know that I went from acid to base. All right. So this was an acid clear. I dropped in the base, drop, until it looked a little bit pink. Now, what I like is as soon as it gets like really pink, now I know I made it a base. And I was trying to get to neutral. So I kind of want like right between clear and all the way hot pink. So I'm going to look for like the first drop that makes it like really light pink, because I'm like, okay, that's when it first is just like one drop over neutral and it just became then I know that I like am really close, at least one drop away from when it hit neutral. So if we were in the lab, I would challenge you to try to get this perfect light pink. So let me show you what that looks like. So this person, and you would be doing this if you were in the lab, is adding the base through this burette. And that helps them to just add a little bit at a time. And you see, every time they add some base, it turns hot pink right where the base hit, because bases turn hot pink. But as soon as you like swirl it around, the acid kind of just like cancels out or neutralizes that base. So it kind of disappears. So I'm going to keep adding drop by drop of base. And I'm going to keep watching. Okay, the pink still disappears. It's still more of an acid than it is a base. I keep adding a little bit more base, seeing that pink. Oh, it disappears. I'm looking for the point when I go like one drop over and it will stay a light pink. So I know I'm right around in between acid and base and it is neutral. Okay, so I keep adding a little bit more base and it keeps disappearing because the acid kind of overtakes it. And then finally the pink stays and it means like I finally just added so much base that now it's more basic than it is acidic. The acid can no longer cancel it out. So now that it's pink, I know that I finally like reached that neutralization point and I go, okay, how much did that take? Okay, it took right around 25 mils. And I started with 25 mils of acid. So if my base, I know my base was a 2 molar, and my acid, I don't know what it was for molarity. That's what I'm trying to figure out. But I at least knew how much I had. I could measure that. I had 25 mils of it. And now I see it took right around 25 mils of that base to neutralize it. So then I'm like, okay, they must have the same molarity. It must be 2. It's not always that simple sometimes, and maybe it took twice as much acid than base. Okay, so what is titration? It's when you have some sort of unknown acid or base. In this case, I had an unknown acid. I knew it was an acid, but I just didn't know how strong. Is it super dangerous or not so bad? What's the molarity? Remember, that's how strong it is, how many moles per liter. So what's the molarity? I do know the volume. I know that I have 25 mils because at least that I can measure even if I don't know what it is. And I also know what I put in this burette. And again, the reason I put it in the burette is so that I can just add it slowly and add it drop by drop. And what's in the base is my known or my standard. And I know that that's a 2 molar base. And then I measure, okay, well, how many drops does it take to get them to like balance out? And then I can figure out if they have the same molarity or if one has twice as big a molarity. So what titration is using a known to add it drop by drop with an indicator that changes color to figure out the molarity of an unknown. And we'll do the calculations next.